Hello everyone, how's it going? Thanks for joining me here today. Well, we're doing this live, and so I'll give you guys a chance to catch up here and confirm that my audio is sounding good, video is sounding good. We got Sammy here with us on the chat. Thank you everyone for joining us live, and if you're watching this later, hey, thanks for checking in. I am going to review all different types of offsets today, and so whether you're brand new to CNC or you're an experienced operator, I think there's going to be some information here that you're going to find useful, and maybe you'll come back to. We're going to talk about all different types of offsets. So all right, let's check here with the chat. Bernie, hey, how's it going? We got Pete, Greg, Joe, Mr. David Brown, how's it going? No audio there, Nick Wallace. Well, I'm getting feedback that our audio is good, so I'm going to dig right into this, and let's get started here. So welcome. My name's Cory. I'm the Customer Experience Manager at Avid CNC, and thank you so much for learning more about our equipment and the possibilities of these tools here. If you're interested in anything or want more specifics, please go ahead and shoot us an email, support@avidcnc.com, and check us out, like us on social media at Avid CNC. So Avid CNC, I just want to touch base briefly on our mission here. It's simple to the point, but I feel like is worth repeating. We are here for you, and we want to develop professional machine tools that provide exceptional value and are accessible to everyone. And we really are geared towards this mission, and it helps us every day drive decisions. And so please, we'd love your feedback on our execution of that mission, and would love to bring you on board with that mission. So I'm going to talk about three different types of offsets today. I'm going to talk about offsets in CAD, I'm going to talk about offsets in CAM, and then I'm going to talk about machine offsets, and that's going to be in Mach 4, but this is going to be pretty generic G-code machine offset. So it isn't Mach 4 specific, but we will be using Mach 4 today as a reference, and it is our recommended controller. And so let's talk about where we're going to start here. And I guess, an offset is a datum coordinate and a work coordinate, and the space between those two, and that is what an offset is. And we can set offsets up so everything is at our machine coordinate 0, 0, and we don't have any offsets. That is our machine 0, 0, it is our work 0, 0, and we can start with everything in that lower left-hand corner and move up from there, or in the very center of our machine and move out. Or we can stack offsets. And so we can stack offsets in CAD, we can stack offsets in CAM, and we can do offsets in the machine controller itself in Mach 4. And so we're going to talk about those. So what is a datum, right? And so I think this is my favorite definition of a word that I've ever discovered here. A datum is a piece of information, and that's a lovely description of a word, right? And so that's the datum, and this is a Cartesian cross here and XYZ, but I like to describe datums in other ways so we can dig deeper into why offsets are hard to comprehend sometimes, and what tools I use to help kind of make that easier. So I think about this as a datum, right? When Mr. Ross there starts a beautiful mountain or happy little tree, he's choosing a starting point. He's choosing a datum. When we have a face-off, that is a known starting point. It is an agreed upon point that we can start from. And when we're playing football, and this is an analogy we're going to dig deeper into, the datum could be the line of scrimmage where the ball is currently placed. It could also be any other marker on that field, and we're going to dig a little bit deeper into that example here coming up. And so we are going to be using a sample project today, and this is a quick example of what a machine would look like. It has 7 3.5 by 3.5 inch squares attached on the spoil board. So I'm not going to talk about work holding in this discussion, and so these are just 7 pieces of material. Let's say they're double stick taped to the machine bed, and they're in known locations. And so we had some type of measuring or way to put them in specific spots on that spoil board. And so this is going to be the example we're going to be using to help describe these different offsets, and more importantly, the techniques to take advantage of these offsets. And so one thing I want you guys to know is we're going to go through a bunch of different stuff, but at the end, if you've ever seen a machine go between 2 or 3 stations with rapid order, and then it goes from station 1 to station 2 to station 3 and then back to station 1, and then it automatically does that over and over again, and you see the operator getting a ton of production out of that machine, well, I'm going to teach you how to set your G code up so you can do that too, and so you can really crank up the production capabilities of your machine using these offset techniques. Okay. All right, so here's a top-down view of this same project, and you can see here we got our machine bed, and we have these 7 3.5 by 3.5 squares that are sitting on our spoil board. And let's go ahead and pull VCarve up, and I'm going to be doing some work in VCarve. There's some links in the description below for some Fusion offset stuff. Lars and John both have done a phenomenal job talking about offsets within Fusion, and links in the description below. Check that information out. It's going to combine really well with the other information in the rest of this video, but I'm not going to go deep into CAD offsets in Fusion, but Lars and John have, so check that out. And so, okay, we got VCarve Pro here, and so what I have here set up is a single-sided operation, and my job size is 48 inches wide by 12 inches high, and I have a 1-inch thick material. My zero position is on my material surface, and my XY datum position is in the lower left-hand corner. So this is the first area that we can add offsets if we wanted. We can use this XY datum offset. And so if you notice here, if I change this to 12, 12, so I add an XY offset to my datum point, and then I grab some measuring lines here, you'll see that my material here is actually 12 inches from the actual zero position. So this is the first area that you could add an offset into your workflow. So you can add an offset before you ever even draw a vector. So we are not going to use that. We are going to have our zero position in the lower left-hand corner of this 48-inch by 12-inch material, but that is the first place you can do an offset. So we're going to go ahead and click OK, and now we have this. I am going to delete these guidelines. Perfect, get those out of our way. So here's our 48-inch by 12-inch spoil board, and I guess the first thing we should do is we should draw our 7 work pieces. And so let's go ahead and draw a square. I guess this is the next area where we can kind of set offsets. Our anchor point, whether it's in the lower left-hand corner or the middle, is a way that we can determine an offset. I'm going to use the lower left-hand corner. I'm going to choose an X coordinate of 6 and a Y coordinate of 3 for my lower left-hand corner, and that's to match those 7 pieces that are on that fixture. It's a 3.5 inch by 3.5 inch square with and I'm going to create the first of those 7 squares. And so there's that right there. And so I'm then going to array this square. So we can go to the array copy, and I want 1 row with 7 columns, and I want to use an offset spacing. And that spacing is going to be 6 inches along the x-axis. And so what that means is the lower left-hand corner of one piece is exactly 6 inches away from the lower left-hand corner of the next piece. And so we're going to go ahead and copy those, and you're going to see my 7 work pieces now are in VCarve here. And so these are representing the perimeter of those 7 work pieces. And so let's go ahead and bring in a DXF. And this is going to be a DXF of our logo here, and I want to scale this DXF, so let's go ahead and go to scale, and I just want it to be twice as big, so I'm going to put 200% in here. And what I'm going to do here is I'm going to put a letter of of our logo in each of these boxes. And so I'm going to take the C and I'm going to drop it in this box, the N into this box. Oh, got them mixed up there. Here, I can move them all at the same time here if I know how to select it right. And I just need to get them close to the box here because I'm going to use another offset tool in VCarve to give their final position. So I like to use this align selected objects. And so if I select the letter and then I hold shift and select the box, and then I center to that, it's going to center my letter inside of the box. So we're just going to go ahead and center all of our letters. So Sammy's on the chat, but I can see a little bit here. Are we coming from all over the world? Is there anyone who can claim to be the farthest away from North Bend? Who's the farthest away from North Bend, Washington? All right, here, so we got our letters. And so I guess I can mention this is all CAD offset, right? Like these letters are all based on 1, 0 coordinate, and this is based off of a CAD offset. And so let's make some toolpaths to this. And we're just gonna do some pocketing toolpaths with a 1/4 inch end mill. We're gonna go an 1/8 inch deep, and I'm gonna select our letters. And you're going to see we got the letters selected there. Now, because VCarve, we're not designing each 7 individual piece, we're not seeing those, but I can go through here and do a little trick here so we can see those. I can go ahead and select the opposite. And this isn't a toolpath that I'm going to use, but more I just want to use it as a representation of kind of the perimeter of those squares. And so you can see here we're cutting the logo out of each square. And so this is a CAD offset of these letter templates. And so let's talk about a way that we could do a CAM offset of these letter templates. And so let's make a new pocketing toolpath for just the letter A. And so we're going to call this letter A. And I want to reset my preview here. And if we run just the letter A, you'll see that we just cut it in that one spot. And if I go back into my toolpath creation area and I select letter A and I go to this array copy toolpath option. And now if I set 7 columns in 1 row with an offset of 6 inch, array toolpath A, and I calculate, watch what it does now. So now it actually spreads those A's over those 7 different spots. And so that's a trick where you can set up an offset in your CAM to program something in CAD once and then multiply it out, right? So if you know that you're going to be cutting the same image on a board, and rather than copying that image into a bunch of different vectors and making sure you're selecting all of them, if you can do the toolpath for one of those images and then array those vectors with an offset in your CAM, you could be really successful with that offset, right? So that's another way that you could increase your efficiencies using offsets in CAM. And so yeah, so we talked about array, we talked about drawing. Is there any other questions right now about offsets specifically in VCarve that I can answer for you guys? So I'll give you a couple seconds. Let's check in here. We got JD from Albany. We got some people from Kauai and Canada all over. Thank you so much for tuning in. Cool. Well, if you have more questions about VCarve and offsets, put them in the chat or shoot us an email and we'll circle back up with you, okay? So last week, Sammy talked about zeroing, and we talked about finding, a zero position on your workpiece. And one example we used was this image here, where our work 0, 0 was at a machine coordinate at 10.5. And if I would encourage you to go and watch Sammy's talk on zeroing, because I'm really building on the principles that she set. So when I like to think about machine coordinates and work coordinates, I like to think about it like a football field. And why I like to think about it like a football field is because we have a field of play. So I have a known perimeter that I need to work within. And the ball or line of scrimmage is a variable. It can be moved all over the field. The ball, at kickoff could be right on the 20-yard line. Later in the game, it could be on the opponent's goal. And so we can place this work coordinate anywhere we want on the machine. Now, it's important to remember that if you're on the far end of the machine, maybe that isn't the time for a Hail Mary program, right? And so we need to make sure that the zero position we're setting up on the machine can execute the size code that we have. And now there's a feature in Mach 4 called soft limits. And let me just show you that real quick. That is right here in our jogging tab, and you click soft limits on and it goes green. And soft limits will tell you if your G code is going to operate outside of the field of play. So essentially soft limits is setting us up with a perimeter to our field. And I would encourage all users to operate with soft limits on. So we can set the line of scrimmage anywhere we want. And generally speaking, this is with a G54 command. And Bobby Wags is just such a great example of what a 54 can do on the field, right? You can place it anywhere you want, and it's very common. But there's other offsets that are also very valuable. And so these are the G55, G56. Lars and John talk about them in the video below. But I want to talk about how I think about leveraging those offsets in production manufacturing and manipulating our G code, because I think one thing that CAD CAM has become a lot easier to produce, and I love that factor, but I want us to be able to look at the G code and understand that setting offsets and adding those after the fact is something that's very easy to do and is something you should be empowered to do. And so why don't we go ahead and review that. So we're going to go ahead and we're going to pull up VCarve here, and we're going to start this file over a little bit. So instead of having a 48 by 12 work area, I want to have a 3.5 by 3.5 work area, right? I want a work area that is the size of one of those coaster blanks. And so let's go ahead and take the A, and we'll go ahead and bring that over here. And just like before, we can use this and we can align to material, and we can center that right on our material, right? And so let's go ahead and delete these toolpaths out of here. I just want to do a little housekeeping. And let's make a new pocketing toolpath for this A. And so it's going to be same parameters, 1/4 inch end mill, 1/8 inch deep. We're going to do pocket A, and we're going to calculate. And so this is going to give us this nice little A. That's perfect. I also want to do the V. I want to show you guys the V. So I'm going to select the V. I'm going to align it to the material. I'm going to do a new pocketing toolpath. That's for the V, and I'm going to do pocket V, and I'm going to calculate here. And you can see the A and the V are both centered on our workpiece. And running this program on the same workpiece would obviously not be ideal. But the important thing is that both of these are using the same offset point from the corner. And the corner isn't the fixture, the corner is the workpiece. And this is where we're going to be able to take advantage of some serious production capabilities with your machine. So I have these two pocketing toolpaths. I'm going to save these as G codes. So let's go here and go to the Save Toolpath. It says Pocket A. I got the Avid CNC post processor here in VCarve. If you don't already have our post processor, check our website or look at V10 of Vectric, and it's automatically included. We're going to go ahead and save this toolpath. We're going to do Pocket A live. And then we're also going to do the Pocket V Live. Perfect. So I have those two pieces of G-code saved in my folder there. So in the first example where we did the 48 by 12 inch piece of material, we had our G54 set in the lower left-hand corner. And generally speaking, for this discussion, the machine coordinate 0, 0 and our G54 0, 0 were the same, right? We were all the way lower left-hand corner of the machine, and that's where we started. And so you would see we would come, this would be our 0 position, and we would run all 7 of those toolpaths, A, V, I, D. Well, with the second type of programming technique, what we did is we've shifted the G54 coordinate to the lower left-hand corner of our workpiece, right? And so that's a 3.5 inch by 3.5 inch blank. That's the G-code that we just created. And so let's look a little bit closer here. And so that's the lower left-hand corner. That's where the football is. That's the line of scrimmage. And here's where the interesting part of offsets can come into play and how I like to think about it. And so when I think about offsets, I think about it as more footballs placed on the field. I have more starting points for programs, and I can change those starting points. And so for this example, my starting point is 6 inches. So my G54 offset is 6 inches on the X. My G55 is then 12 inches on the X. It's 6 inches to the left of it. Now, these particular 6 inch increments, I want you to be empowered to change these to whatever size work pieces or work area that you have, right? These are examples of offsets. But what I want to show you is that if we place multiple balls on the field, we can have multiple G-codes set up for that. And so if you've ever wanted to do production where you have 2 or 3 pieces loaded into the machine and it bounces from one to the other, rather than drawing that in CAD, you would draw individual parts in CAD, and then you could set up your fixture in a number of different ways. And this is where it's really powerful, because if you really take this approach, you would have a lot of individual CAD programs, and then you would be multiplying those based on your current demands. And so using a coaster as an example, if you had 200 different coaster designs, using this approach, you would have 200 individual files, but then you could make an infinite amount of different production files based on your current demands. And this is where it's really, really powerful. So we have our current offset, G54, and that's at 6 and 3. And then our G55 is an additional 6 inches east. And so that's at 12. Our G56 is an additional 6 inches. That's at 18. And so on and so forth. And so we get all the way to G59. But what about that 7th piece of material? So we only have up to G59 as an offset. And so this is another thing that Lars and John both touched base on, but this is a G92 offset. And a G92 is a very special offset because it essentially says, hey, whatever your position in now, I am resetting that live in the G-code. And so within your G-code, theoretically, you could have multiple G92 commands. So every time you ended this program, you would put a G92 minus X minus 6, and I'll show you this in the G-code, and that would essentially assign this position now as -6, and then when the next line of G-code ran up and it said go to 0, 0, it would shift over 6 inches and it would continue here. And then when this program ended, when you used a G92 X -6, it would reset that position as -6. The next line of G-code would call for a 0, 0 command, and it would shift over to the next position. And so on and so forth. And so rather than using G55, G56 offsets, you could use G92s if there are known distances. And this is another area where I think if you can practice with some simple projects, specifically for honing your offset skills and manipulating your G-code, I feel like this can really turn the volume up on production capabilities, right? And so if we're doing a number of the same operation, this is what we're talking about. And so we covered a little bit today on CAD and CAM. And let's dig into some of the machine offsets, right? And so we covered those. Let's go ahead and bring up mock and some of this code, and let's look at that. And so here we go with mock. And so I guess first let's go ahead and load our G code for our letter A, Pocket Live. And you're going to see, here's our letter A. It might be a little faint there. Let me see if I can zoom in for you. We can go ahead and increase our display settings. And so I'm going to increase these to 40. See if I can make this a little bit bigger for you guys. There we go. And you can see we have a single A there. And so this code is for one single A. And so I'm going to go into the Edit G Code button here. And it's going to bring open our G Code editor. And I would encourage you all to have, Google at your side. And I'm regularly searching the definition of G codes. And this might be a little bit hard to read, but I will have an example of the G code down below and where I put the G command so you can see it after the fact. Someone's asking, do you need to turn soft limits on every time? Generally speaking, yeah, I do like to turn it on every time, but the machine doesn't require it to move. It just prevents you from crashing into your physical limits. And so here's our G code. We have some information here at the front. We have the name of it. It's our post processor. It gives us a material size, and it gives us the tool used and also then our tool path. And just underneath the tool path, there's a G command. It's a G94, and this tells us that we're going to be doing whole number moves. And just above the G94 is where I like to put my offset toolpath. And then when we scroll down to the bottom, there's an M5, M9, and M30 command. And this is to turn off the spindle, turn off any coolant or relays, and rewind the material to the top. So that's what those three mean. So I'm going to not copy those three, but I am going to copy the last line of code, which is G00X0Y0. And I'm going to copy the rest of this code all the way up. And I'm going to hit Control-C, and I'm going to copy it. And then I'm going to insert it just above that M5 command. And so essentially, right now, I have duplicated my code. So I have the same A in here twice. And so on the first line of code above the G94, I'm going to type G54. And down in the second group of code, just above the G94, I'm going to type G55. Now, in the second group of code, I also like to eliminate my spindle on command. So that's an M03 command. And I like to do that because there is a dwell involved with your spindle turning on or your router turning on. We tell the machine, hey, whenever you turn the router on, wait 4 seconds. I don't necessarily want the machine to sit there and wait 4 seconds because my spindle's already on. It's just going to sit there and wait, and it's not going to go. So I'm going to go ahead and delete that S18,000, which stands for my spindle speed of 18,000 M03 command. I'm going to go ahead and delete that. And so now I've copied my toolpath, I've deleted one line of code, and I've added two G54, a G55 code and a G54 code. And so I'm going to save this now. And now when we go ahead and open up mock, you'll see we have a preview of two A's side by side. And so let's do this scaling. So I'm going to go back in and I'm going to edit the G code. I'm going to bring this back open. And I'm going to go ahead and copy the second group because I know I already have the M03 command removed from that. So I'm going to copy this second group of code all the way up to the bottom of the first group. I'm going to copy that, and then I'm going to paste this, and I'm going to add I have G54 and G55 already, so now just above this, I'm going to add my turn this one into G56. And I'll do it again. And I'll turn this one into G57. And then again, and turn this one into G58. And again, and turn this one into G59. So essentially, I have now taken that same letter A, and I have scaled it to all 6 positions in our G code here. 1, 2, 3, 4, 5, 6. So you can see it's in all 6 positions. Well, I also wanted to show you a G92, how you could add a G92 if you ran out of offsets, or if you just prefer to use a G92 as an offset. And so I'm going to go back into edit code. And so one thing at the end of your code, it's going to remember the last offset you were on. And so if you want to go back to a G54 offset, at the very end, if you put a G54 just before your M05, it's going to reset that as the offset, and your machine will be in that offset coordinate at the end of this sequence, right? So if you don't want to end on a G59, just put a G54 at the very end and you'll end on that offset. But let's go ahead and copy this last line of code. So we're going to copy position 6 essentially. And so we're going to copy the position 6 G code. And I'm going to insert it again. So perfect. And now instead of G59, it's going to be a G92 X minus 6.0. Let's see if I can get this right. What code triggers Avid's relays? Pete's asking. Well, that's a great question, Pete. So M03 is going to trigger our relay for the spindle, if you have our spindle set up. And then we are going to have M7 and M9 are going to trigger relays 1 and 2. And those are also called mist or flood coolant. And so that relay information is available on our Mach 4 instructions. And if you haven't checked out our new electronics manual, please navigate to our NEMA 34 or NEMA 23 plug and play listing, and you'll find a complete manual there for our electronics. And so now when we go ahead and save this, looks like I didn't do my code right. You see how it didn't preview here? That's telling me that I had an error in my code manipulation. And so let's go back here, and I believe that error was in my G92 request. And I think it's because it needs to be a negative before Z minus. What do I got going on here? Why is my G92 not working? X minus 6.0. Yeah, that should work. Let's see here. It's not working. Well, I'll dig into why that's not working. So we're going to go back into editing our G code. And this is what I mean by we shouldn't be afraid to explore this a little bit. You know, I didn't plan on making this mistake, but part of me likes you watching me fumble through this, because it's how I can establish what is making this G code wrong, and then we can navigate through this, and we can repair this, right? So we're going to go ahead and delete that last G92 command that I had entered, and I'm going to resave this, and then I'm going to load it back in and see if that. Yeah, so it is that last G92 command that's corrupting my G code. Here you can see now we have the preview of those 6. So let me figure out why pocket align is missing left bracket. Oh, there we go. Sammy's helping me out from the. Yeah, maybe you guys can help me out from the chat. Where am I messing up here? So we're going to go back in, we're going to duplicate that last bit of code. And we're going to copy that back in. Pocket A line is missing. Okay, maybe that got it fixed. G92 X negative 6.0. Still not loading. Well, I'm going to have to figure that out. I don't see anyone in the chat. They say left bracket missing, but I'm not sure exactly where. But we'll definitely have a link down below here later with that correct code there for G92. So we covered some CAD offsets. We covered some CAM offsets. Really what I want to talk about is this ability to separate out your individual programs and scale them. And I hope you were empowered and enlightened today. And yeah, let's see if there's any other questions in the chat. We are shipping machines all over the world. So please, no matter where you're coming from, if you're interested in CNC, we want to help you get involved in this technology. We feel it's really empowering and would love to help you no matter where you are. Our machines ship all over the world. Okay, well, I'm not seeing any fresh questions here. So next week, we're going to have Tim Sway on our live stream, and Sammy and Tim are going to talk about a number of different things, not limited to hollow core doors or upcycling or CNC machines. Maybe they'll be able to fix my G92 snafu here with today's live stream and give you an update on how to actually copy and paste that successfully. And yeah, it should be very interesting. So yeah, if there's no other questions, thank you guys so much for tuning in, especially this long. 38 minutes on offsets is a lot to swallow. So really appreciate your guys' support. Thank you again for everything you guys do. And Tiller is our shop dog of the week. And yeah, thanks so much. Cheers.